Hello, and welcome to my YouTube channel, Reading Little Blue Books. Aloud, while stoned. In this video, we're going to start a new Little Blue book. And it is Little Blue Book number 191. Again. Occasionally, in the Little Blue Book catalog, you come across this, two different books under one number. This one is Evolution versus Religion, and the other one was Evolution versus Dogma. This one is written by Ramsden Balmforth. And did a little research. The Reverend Ramsden Balmforth was a notable Unitarian preacher in the late 18th and early 19th centuries. He was known for his progressive views and his efforts to promote rational religious thought. Unitarianism during this period was characterized by a rejection of the Trinity and a focus on the oneness of God, often emphasizing ethical living and social justice. Balmforth's contributions to Unitarian thought and his leadership in the religious community were significant during his time. And they must have been because they impressed E. Hadelman Julius enough to have him write a Little Blue Book. And thanks to ChatGPT for that little description of the Reverend Ramsden Balmforth. And this Little Blue Book does not have a copyright date. It doesn't have a list of chapters, which there are chapters. It just gets started from the get-go. Page 1, right into it. And whoever had this has written, just like marked all over the front of it. I don't know. I got it in one of my collections. Okay, so let's go Evolution and Religion, or Evolution versus Religion. Chapter 1, The Evolution of Worlds. There is no spectacle more wonderful or more awe-inspiring than that of the starry heavens. Absolutely true. As Emerson once said, if the stars came out only once in 100 years, all the world would camp out to witness the marvelous sight. But familiarity breeds indifference. An indifference which would disappear if we would cultivate more deeply the spirit of the psalmist and the poet. To see these millions upon millions of worlds pursuing their timeless way, some of them perhaps bearing, like this earth, their enormous freightage of life, and floating onward through space at the rate of some 65,000 miles an hour. To think that some of those stars, though a million times larger than our Earth, are apparently but as a pinpoint in space. To call to mind also the millions of darker bodies which we do not see, outnumbering the visible stars, so that the whole seems as the sands of the seashore. And to remember, at the same time, the beautiful order and system by which these innumerable worlds are kept in their destined orbits. All this is wonderful and awe-inspiring indeed. And it is. Let us try to get a clearer idea as to what evolution means. Briefly, it means that by adaptation or natural selection, both these words or phrases concealing deep mysteries, a few simple and at one time perhaps invisible forms of life have, through countless ages, developed into the myriad complex forms of plant and animal life which we see around us today. But the evolution of worlds began, of course, long before this, long before life as we know it existed on the earth. It is that phase of evolution of which I wish to speak in this discourse. One of the most fruitful speculations respecting this evolution of worlds was made by the great German philosopher Immanuel Kant in the year 1755. He affirmed from his study of the heavens that the earth, the sun, the planets, and all the thousands of minor bodies which form the solar system originated from vast contracting nebula or bodies of the fire mist, such as we now see in various parts of the heavens. 40 years later, Laplace, the great French mathematician, confirmed Kant's theory from the side of mathematics. Later still, Sir William Herschel constructed telescopes by which, in conjunction with his illustrious sister, he discovered, in their long night watch of the heavens, thousands of these nebulous bodies about which Kant and Laplace had speculated. Later still, in 1864, Sir William Huggins discovered that some of these nebulous bodies were actually, as Kant had surmised, gigantic volumes of incandescent gas. The primitive fire mist for which worlds are evolved, from which worlds are evolved. And some 20 years ago, Sir Norman Lockyer, in his work on inorganic evolution, pointed out that just as we can trace in this world of ours the evolution of the myriad complex forms of life from a few simple forms, just as a geologist can trace the development of the outer crust of the earth from the latter strata to the chalk and limestone beds and the earlier strata from the Laurentian and Cambrian rocks, and back beyond those to the volcanic rocks at which the geologist must stop. So the astronomer can trace the constitution and development of the stars and the nebula by the light they emit. The development, that is, of the most highly evolved stars or worlds back through a long series from those which existed in a primitive state of incandescent fire mist. Sir Norman Lockyer, in his books, gives a diagram arranged after the manner of a diagram of geological strata, showing the chemical constitution and development of worlds from the simple fire mist to the more complex constitution of the stars. And a few years ago, Professor Darwin published a series of lectures in which he tells us that in the later stages of the evolution of a nebula, the figures, which it assumes are so curious that they remind one of the protrusion of a filament of protoplasm from a mass of living matter, the first attempt at feeling after something outside us. And I suggest, he says, that we may see in this almost lifelike process the counterpart. Can't turn the page, man. Having trouble. The counterpart of at least one form of the birth of double stars, planets, and satellites. Other astronomers have frequently pointed out the development of a nebula in its earlier stages frequently takes the form of a spiral or seashell. And thus, we see in the birth of worlds a faraway primitive type of the birth of forms of plant and animal life on our own planet. And then there's a quote right smack in the middle. Striving to be man, the worm mounts through all the spires of form. It's a quote, doesn't say from who. Long ago, biologists showed how, in the course of this development from animal to man, we each one of us pass through the various stages which our ancestors passed through in their descent from the life forms of the earliest ages. Now we see that these forms have their still earlier types in the birth of worlds. Truly, we may say, with the psalmist, "My frame was not hidden from thee when I was made in secret and curiously wrought in the lowest parts of the earth. Thine eyes did see mine on perfect substance, and in thy book were all my members written." And we'll just pause there for a hydration break, brought to you by my friend Maddie. Now let us glance at the evolution, pardon me, of a nebula. A nebula is an immense body of incandescent vapor or fire mist. Love that. Fire mist. Already, as our astronomers tell us, some 120,000 of these nebulae have been discovered. Wonder how many we've discovered since this was written, 100 years ago or so. They're not stars. They're the stuff out of which stars and systems are made. And many of them are so large that our own solar system is but as a tiny cloudlet compared to them. These immense bodies, in obedience to the laws of motion, what gives them their motion is one of the mysteries, revolve at an incredibly furious speed, and the gradual dispensation of heat and the consequent contraction of their particles through their course of uncounted ages tends to produce changes in their form. They may become spiral. They may, at a later stage, possess rings like Saturn. In these changes of form and the consequent alterations of mass and momentum in the various parts, large sections of the nebula world, through centrifugal motion, detach themselves and again, in obedience to the laws of motion, would begin to revolve like the parent body. And in obedience to the law of gravitation around the parent body at such a distance as its size, pardon me, its size in relation to the parent body and to other planets would determine. As portion after portion of the larger parent mass was whirled off into space, there would evolve a system of which our solar system may be taken as an example. As the temperature of these great masses of matter cooled, various elements in the mass would tend to combine. Chalk, or limestone, for example, is a combination of elements. If submitted, say, to the white-hot heat of the sun, these elements would separate and dissolve, first into liquid, then into gas. The oxygen would be separated from the calcium, and the calcium and the oxygen from the carbon. And so, indeed, all the combinations of elements would be dissolved in the immense heat. But as the temperature cooled, some of these elements would tend to combine. They would form a thin, hard outer crust, which would slowly tend to become slightly thicker and harder with the continual dissipation of heat. This process would go on through indeterminable ages, the various elements combining as their nature and temperature determined, some into water, some into air, some into the various kinds of metal and igneous rocks which we find on the crust of the earth today. The water would form the primeval seas and oceans, as the smaller body revolved around the immense mass and heat of the parent body. These waters at certain seasons would be vaporized, only to fall at other and comparatively cooler points of the orbit in deluges of rain and hail, which would form rivers and lakes. These, in their turn, wearing down the surface of the already hardened crust, and so forming the first deposit of aqueous rocks, which we find in the crust of the earth today. The waters on the surface of the earth, that is, the lakes and seas, would naturally be the first parts to cool to such a temperature as would allow of the existence of conscious or subconscious life. And as a matter of fact, it was in the primitive seas that the first simple forms of plant and animal life appeared, as found fossilized in the lowest strata of the earth. The book of nature. From these simple forms of life, all life as we know it has developed. But that is another story. And I got to scratch my nose. And hydrate, kid. But where is the evidence for all this to be found? It is found in the earth itself, in the sun, in the planets, and in the stars. Take the earth, for example. It is a matter of common knowledge that the interior of the earth is still in a molten condition. That is, our particular planet has not yet cooled all through. The deeper we descend into the mines, parts, the higher the temperature becomes. In some parts, hot water bubbles out of the earth at a temperature high enough to cook food. In other parts, molten lava is poured out in streams by volcanic action. The interior of the earth is still probably molten liquid. Some years ago, a deep hole was bored near Leipzig in Germany, one of the deepest holes ever made. The drills were driven more than a mile deep, and it was found that the temperature increased on the average 1 degree with every 66 feet of depth. And at the bottom, the temperature was 132 degrees. Another mile, and the temperature at the same rate would have reached boiling point. As the diameter of the Earth is about 8,000 miles, it is obvious that our deepest mines pierce only the skin of its crust. The shape of the Earth also shows that it was once in a molten condition. That is, it bulges out at the equator, much the same as an orange bulges at the center. Exactly the shape which a molten or liquid body would assume as it revolved rapidly on its own axis. But the most convincing demonstration of the oneness of substance of suns, stars, planets, and the earth is afforded by the spectroscope. By means of this instrument, a beam of white light passing through an arrangement of prisms or glasses is broken up into a number of colored beams: red, orange, yellow, green, blue, indigo, violet. And these colored beams indicate the constitution of the burning substance, and also whether that substance is in a solid, a liquid, or a vaporous state. So wonderfully delicate is this method of analysis that a single grain of soda, if mingled with 1,000 times its weight or bulk in other substances, can be infallibly detected. The rays, of course, are submitted to very great magnifying power. Now, the elements of which the earth is composed, iron, calcium, sodium, carbon, magnesium, etc., are by this means detected in the light given out by the sun and stars. That is, the elements of which the earth is composed, submitted to intense heat, give out the same colors, or the same gradations or shades of color, as the light of sun and stars. Sometimes, indeed, an element is discovered in the sun before it is discovered in the earth. For example, in 1868, Sir Norman Lockyer discovered during an eclipse that the light of the sun contained evidence of the presence of an element which was then totally unknown to chemists. This new element was named helium. That is, the sun element. 27 years later, Professor Ramsay was examining a rare piece of mineral from Norway, and from this mineral, called elevite, he extracted a small quantity of gas, which was quite unknown either to him or anybody else. On applying the spectroscope to bring up an analysis the beams of light which the burning mineral emitted, it yielded, to his amazement, the light of helium. That mineral Sir Norman Lockyer had discovered in the sun 27 years before. Thus, once more, the same elements which go to form our earth are found in the sun, in the planets, in the stars. Take one element only, carbon. It is everywhere, in the trees, in the earth, beneath our feet, in the air, in coal, in diamonds, in the incandescent lamp, in the food we eat, in the blood, in our very bones. And it is that same substance, carbon, which forms the glowing solar clouds of the sun, and which, now in our bodies, myriads of ages ago formed part of the sun itself. No wonder that man in ancient times bowed down before the sun as the Lord of life. But we see that the sun is only a part, in point of size, a comparatively insignificant part of the world. Let us rather bow to the Lord of the world and say, "Whither shall I go from thy spirit?" or whither shall I flee from thy presence? If I ascend upon into heaven, there thou art there. And if I make my bed in the grave, behold, thou art there. Search me, O God, and know my heart. Try me, and know my thoughts. And lead me in the way everlasting. But now we have reached a stage at which, by the cooling of its temperature, got to turn the page. A world, say our Earth, came into existence, and various elements began to combine as we now find them. Pause for hydration. How, by what means, did the germs of conscious life come into this apparently dead world? I say apparently dead, for after all, the quickening spirit of life must have been ever present. There are some very beautiful speculations and suggestions on this point arising out of recent discoveries, but these I must leave over until my next discourse. Let us pause here and ask the meaning of this wonderful panorama of the universe. Has it any meaning? There are some people who try to read that meaning by a study of the past, and to a certain extent that is well. There are others who go further and say that the past, even in its physical or material aspects, determines the present and the future, and that if you happen to be born at a particular moment on a particular date or under a particular star, your destiny is determined by your birth and by a long chain of circumstances stretching far back into the past, over which you have virtually no control. Now, on these matters, it is well not to be dogmatic. Fate and destiny are great mysteries, and we know little about them. And yet, we need a guide upon this uncharted sea of infinity. What shall that guide be? Shall it be the theory that we are the quips and sport of fate, subject to a certain number of etheric waves or vibrations which make up color, taste, touch, smell, form, and sound, which impinge upon us only to determine our particular fate and destiny, because we happen to be born amid their swirling ocean of a particular moment in this infinite waste of time? Or shall it be that being endowed with this thing called mind, will, personality, which rises above and informs and dominates the world of vibrations and of atoms, we cast our eyes to the future rather than to the past, and make this spiritual and material framework of things, even its unseen and mysterious waves and vibrations, the servant and not the master of our life. Let us remember that all our calendars and divisions of time are largely artificial. That as men are born in this or that part of the world, so they are born under this or that calendar, the Roman, the Jewish, the Gregorian, the Arabic, the Chinese, and that the days and the months of the solar year vary in accordance with the calendar you adopt. Also, that in the millions of births which are constantly occurring, there must be scores, perhaps hundreds, which take place at exactly the same moment of time. And it is hard to believe that all those souls which are born at one and the same moment, under a particular star, as the saying goes, have exactly the same character, temperament, and destiny. No, it is not the stars. It is our inner self, our mind, thought, and will that largely determines our character. And again, though the years and the order of the season recur, time itself does not recur. The world goes on, and with every new generation, with every new birth, something different, something new is born into the world. And it has its own subtle, psychological, and spiritual or spiritual influence upon our life. I mention these things not to dissuade you from the study of the occult, the secret mysteries of nature and of life. We must study these things. We are here but a short time. Before we came into being, there was the eternity which we call the past. After we are dead, there will be the eternity which we call the future. A few moments, and we shall not be. Shadows we are, and shadows we pursue. And yet, possessed by an insatiable but perfectly natural curiosity, man will ever try to pierce behind the veil. I would only utter this note of warning. Let us in all our investigations determine to approach these problems of life and destiny in a spirit and a mood with which reverences will, personality, and ideals, and which regards these in this clash and whirl of atoms as the masters rather than the slaves of those ethereal vibrations, which form the nimbus and the conditioning spiritual machinery of our lives. Professor Darwin, in one of his lectures on the subject, says, "We have seen that it is possible to trace the solar system back to a primitive nebula, with some degree of confidence. But such primitive nebula stand in as much need of explanation as their stellar offspring. Thus, even if we grant the exact truth of these theories, the advance towards an explanation of the universe remains miserably slight. Man is but a microscopic being relatively to astronomical space, and he lives on a puny planet circling round a star of inferior rank. Does it not then seem as futile to imagine that he can discover the origin and tendency of the universe as to expect a housefly to instruct us as to the theory of the motions of the planets? And yet, so long as he shall last, he will pursue his search and will no doubt discover many wonderful things which are still hidden. We may indeed be amazed at all that man has been able to find out, but the immeasurable magnitude of the undiscovered will throughout all time remain to humble his pride. Our children's children will still be gazing at the starry heavens, but the riddle will never be read. I should prefer to add these words to that dictum of Professor Darwin's, not from any theological motive, but from an instinctive desire for truth and justice. These words, in this life. The riddle will never be read in this life. Perhaps Professor Darwin would say that he knows nothing of any other life, and he must therefore be silent about it. It is well to be modest in these matters, and yet it is well also to let our thoughts and conclusions dip to the brighter side of things. We shall see in future discourses whether the evolution theory of the beginnings of life affords any support to the opinion as to whether the riddle will be read, or another chapter of it be read in some other life. Meanwhile, let me conclude with a fable of Voltaire's, which Sir Robert Ball tells in one of his lectures on astronomy. And we'll just take a little drinky before that. An inhabitant of the star Sirius, says Voltaire, went forth on a voyage of exploration through the remote depths of space. In the course of his travels, he visited many other worlds and at length reached Saturn, that majestic orb which revolved upon the frontier of the solar system. As then known, alighting on the ringed globe for rest and investigation, The Syrian wanderer in quest of knowledge was successful in obtaining an interview with a stately inhabitant of Saturn who enjoyed the reputation of exceptional learning and wisdom. The Syrian hoped to gain more valuable information from the sage who dwelt on a globe so utterly unlike his own, and who had such splendid opportunities of studying the majestic process of nature in remote parts of the universe. The Syrian therefore talked gaily on, putting leading questions and opening his own little store of knowledge about the Milky Way and the Great Bear and the Great Nebula in Orion, and then, pausing, he asked what the aged septenarian thought of all this. But the professor remained silent. Pressed for a reply, the sage at last said, Syrian, I can tell you but little of nature. I can tell you indeed nothing that is really worthy of the great theme which nature proposes. For the grand operations of nature are very slow. They are so slow that the great transformations in progress would have to be watched for a very long time before they could be properly understood. To observe nature so as to perceive what is really happening, it would be necessary to have a long life. But the lives of the inhabitants of Saturn are not long. None of us ever lives more than 15,000 years. Where wast thou when I laid the foundations of the earth? Declare, if thou hast understanding, who determined the measures thereof, or who hath stretched the line upon it? Now, just as this fabled inhabitant of Saturn, which is supposed 15,000 years of life, knew little of the ways of nature, just as the gnat, which in the summer morning sun alights on the sheltering leaf of an ancient oak tree, and is dead ere the night frost, in an hour old. Just as that gnat knows little of the wondrous life of that spreading oak, which began its existence hundreds of years before as a tiny acorn, so we know little indeed of this wondrous life and power which throbs through and fills the universe. But just because we know so little, and because we have minds to ponder and speculate, and look before and after, so we shall ponder and speculate at the end. We shall frame hypotheses and build temples of faith by which to guide our pilgrims on earth. Let us take care to frame our hypotheses and build our faith with eyes towards the heavenly gates of life rather than towards the realms of eternal darkness and death. How far we are justified in framing such hypotheses and in building such faith, we shall see when we come to consider the beginning of life on earth. That is the end of chapter 1 of Little Blue Book number 191, titled Evolution versus Religion, written by the Reverend Ramsden Balmforth. No copyright date given. Thanks for listening, and join me in part 2.